My name is Paul Solomon. I consider myself an explorer, adventurer, and truth seeker. I search for answers, and I will travel over mountain, land, and even water until I separate fact from fiction. I will continue digging until I get to the truth. I have investigated various areas in science, including botany, entomology, biology, astronomy, and even medicine, disciplines that are necessary in my field. Truth Quest. Solar power, an energy source that's been around since the beginning of time. But only now are we unlocking its true potential. Solar power involves converting light from the sun into electrical energy. This is accomplished by a device called a solar cell. The solar cell is a voltage source when exposed to sunlight. Light penetrates the glass and upper layer of the solar cell. This layer has a conductive coating. Electrons flow in and out of this conductive coating. A photon strikes a dye molecule absorbed on the surface of the titanium dioxide within the cell, causing an excited state. This releases an electron into the TiO2 or titanium dioxide and exits through the conductive layer. The electron then does its work in the circuit connected to the solar cell. The electrons then flow back into the solar cell where the process is repeated. Here in Washington on Cougar Mountain, there's a man named Steve. He wants to use solar power to keep lights running all night long. Now, this will illuminate the woods around his house, ensuring his family's safety. But much like Noah, who was ridiculed for building the ark, Steve has been questioned as to whether or not solar is a logical solution, since the skies are cloudy pretty much all year round.
And you're looking at some weather video from Seattle over the weekends. Cooler and cloudier Thursday and Friday.
I decided to investigate this point of view further and question some of the locals on their opinions about solar power.
I know people with solar lights in their yards, it still works, but I just don't know how much energy we'd be able to pull off the panels in the winter months.
No, it's not viable, and it won't work.
Good, right? It's not good now.
It's not. It won't work very much.
No.
The solar panel idea, it's a science fiction.
We plotted the route to Steve's house and decided it was time to get moving. It's quite a number of miles out to where we have to go. I'm not sure right off the bat, but I know what to look for. As I was driving out, I was thinking about what kind of solar equipment I might be dealing with. It's raining now, pretty cloudy, perfect conditions to test our hypothesis. In order to get to Steve's house, we're going to have to climb a mountain. It's not accessible by cars. I don't know how long this climb is going to take. I could be out here for 7 days. Worse yet, even a week. I have to be really careful because there's a lot of points where I can easily fall. This is really quite a lot of beautiful scenery, but it sure is one big hike. I'm getting a little hungry, but sadly, I don't see any fish here that I could eat. I'm trying to see if there's anybody here so I can find out where he has all his solar equipment.
Oh, good morning, Paul.
Oh, hi, there you are. I was just looking for somebody.
You know, Steve couldn't be here today, but he left me the manual for you to work with the solar kit because we knew that you were coming to do some study on that. That'll be such a good help.
Yeah, I'll get going on it. Where's it at?
You know, we have it right over here. It's pretty obvious.
3 solar panels, 1 voltage regulator, 1 lead acid carb battery, and 2 fluorescent lights. These are the ingredients we will be using to create the solar system. I brought one of the tools that I often use called a multimeter, and this will allow me to measure the voltage that these solar panels are actually putting out. I'll go ahead and turn this on, set this to DC volts, and connect the leads up to my multimeter, red to red and black to black, and so it looks like we're getting about 21 volts, in spite of the fact that the sun is behind the clouds, so we're not getting direct sunlight. So that kind of disproves the whole idea that solar won't work in Washington. We showed you the kind of power we're getting off of 1 solar panel. We have 3. We're going to connect these in parallel, which is going to increase our current 3 times, easily giving Steve the kind of power he needs for his lights. We're ready now to hook up our 3 solar panels to this voltage regulator. So now that we hooked up the solar panels, and we can see by our display we're getting power, we're going to go ahead and hook up our battery. Now that we have our solar system all hooked up, we're ready to plug in our 2 fluorescent lights. With this 12-volt lead-acid battery hooked into our system, we'll have more than enough power to keep these lights burning for many nights. Just think, if we had about 20 of these, we could easily power an entire house. We went back to Steve's and took a voltage reading on a sunny day. Our findings were virtually identical to the days shrouded in clouds. Well, with our solar system complete and our battery charging, no clouds are going to keep us from powering those lights and anything else they might want to hook up in the future. I think Steve and his wife are going to be really happy. On this quest, we've disproved the notion that solar power is useless here in the Pacific Northwest. Clouds or no clouds, the solar panels will produce the power needed during the day, and with batteries connected, energy can be drawn upon throughout the night. But my work is never finished. I'm off on my next quest. Is Bigfoot real?